Hello, welcome to a new virtual tour of the European Southern Observatory, also known simply as ESO. Okay, my name is Farid Char, and with the producer Felipe Zurita, we will guide you on this journey through ESO's La Silla Observatory. So, in my case, I have been a tourist guide of Paraná Observatory for more than 10 years. Um, we have more than 15 years of experience in astronomy outreach and education. And personally, I have a personal hobby, the astrophotography. So I am very involved on this subject. So Felipe, how are you? Nice to meet you
Hi,
today.
hi Farid. Hi everyone. I'm Felipe Zurita. I'm graduate of astronomy in University of La Serena. I'm here for producer and show you all things about the space or the telescope of Observatory La Silla. So we I I too happy to see people from Amsterdam, from Madrid, for different part of the world. So we'll start the show now. And how we start, Farid? Tell me.
Yeah, sure. So thank you, Felipe. So ISO would like to join you with these virtual tours, taking astronomy directly to your home or wherever you are. So remember that you can send your questions or comments through this broadcast. So I imagine you might have a few questions already. So for this purpose, you can leave your comments or questions in the comments section on Facebook or YouTube on this broadcast. So you can give your name and town, for example, and Felipe will is going to mention it. So um, Felipe will be standing by for your questions and to take a look at those questions later. So, also don't forget to share this experience if you enjoy it. You can share simply using the buttons of the like buttons on Facebook or YouTube. Okay, so now let's start this tour. And now we are going to begin with the European Southern Observatory. So, ESO is an intergovernmental organization comprising 16 member states. Its headquarters are in Germany, and Australia has recently become a strategic partner. Okay, Chile is the host state and home to all ESO observatories. Okay, since the 60s, with the purpose I mentioned, ESO chose one of the best places on the planet to carry out astronomy, the Atacama Desert in Chile. So at that time, Chile had started a site exploration campaign to attract international observatories such as ESO to our country. So Chile offered land, and ESO chose the area that seemed best. Okay? So ESO's mission is to design, build, and operate astronomical observatories. And what for? To enable important scientific discoveries and foster cooperation in astronomy. Okay, so now we have a picture um, and in this picture, you can see ESO's three observing sites in Chile. So the first, we have a Paraná Observatory. So this observatory is home to the Very Large Telescope, or VLT, okay? And currently is the most advanced visible light telescope on the planet, okay? In the future, the Paraná Observatory will also host the Extremely Large Telescope, or ELT, which will become the world's largest visible light telescope. And we will also have nearby the CTA, an array of telescopes for the detection of gamma rays. So, and then we have Shahnan-Tor, the site where the ALMA and APEX radio telescopes are located. ESO participates in these radio astronomical observatories with its international partners. And finally, we have La Silla Observatory, the site you will be visiting today. This was the first observatory built by ESO in Chile, 2,400 meters above sea level in the region of Coquimbo. So we are going to visit that place virtually during the next hour. Okay, so now let's travel to La Silla Observatory. Okay, so now we are looking at our planet and we start our journey by land in Europe. Since I must mention that ESO, it's a European organization. Um, on this map, outlined in white, we can see the different ESO member states. So Chile is the host country and home to all ESO observatories. So to see the sites, we will travel to the Chilean mountain range. As we move over the Atlantic Ocean, let me tell you more about ESO's mission. To give you an idea, ESO tries to devise which type of instruments are needed to study the universe, and then designs the pieces, builds and operates telescopes responding to observational requests from around the world, thus encouraging cooperation in astronomy. Okay, so we are almost there. As you can see in this video, we are approaching slowly to the Chilean coastline. Okay, and we are going to uh, arrive now to La Silla Observatory. So you can see what an amazing mountain. Okay, okay. So can you see a mountain range with domes across? Look at the shape of this hill. Does it remind you of anything? Perhaps a horse saddle? Well, in fact, the mountain itself and the observatory later were named after a saddle for horse riding. So over the years, ESO La Silla Observatory has become the perfect viewpoint for studying the universe. It was chosen by the astronomical community as an observational site and at the beginning of the 60s. La Silla enjoys a large number of clear nights per year and a still and dry atmosphere and dark skies far away from artificial light sources, which exist in cities. Okay, so from the air we can see that the La Silla Observatory has many telescopes of various shapes and size. All this underlines the importance of La Silla, a place with a history which nonetheless remains at the forefront of astronomy. Okay, so we have different telescopes, as you can see in this video. You can see the names of the telescopes, and we are slowly approaching the biggest telescope of this complex, the ESO's 3.6-meter telescope. Okay, so hidden among several telescopes, for example, we also have the NTT. The acronym NTT stands for New Technology Telescopes. New Technology Telescope. Okay, so the NTT was a pioneer as it includes groundbreaking technology that nowadays allows us to build giant telescopes. Okay, but now we are going to begin this journey, this tour, with the largest telescope of this complex, the ESO's 3.6-meter telescope, because this is a planet hunting giant. Okay, so now we are going to visit this place. This is the ESO 3.6-meter telescope. Okay, and you can see the landscape from this area. We can see the telescopes there, the entity, for example, the other telescopes, and the landscape from La Silla. Okay, so well, we are going to start with the ESO's 3.6-meter. Okay, so now we are inside of this big telescope. Okay, so something important to mention is that from this exact place, the ESO's La Silla Observatory, more than 1,000 people. So the total solar eclipse of July 2019, and this was a memorable astronomical event that will only be repeated on 28 August of 2231. So from this area, right now we are inside of the 3.6-meter telescope, or 360. as it is commonly called by the staff in La Silla. So the name refers to the mirror's diameter. So back in the mid 70s, it was one of the largest telescopes in the world. So currently it hosts an exoplanet hunter, namely HARPS, and this is a highly specialized instrument used every night to search for other worlds outside our solar system. So what do you notice about the dome from the inside? Well, it's huge. Okay, the altitude from the first floor to the dome is 25 meters. All this structure of the telescope is equal to a seven-story building. So everything seems small here if you compare this with the telescope. So for instance, can you see anyone over here? For example, if I take a look, can you see someone here? Because this place is so huge, yes, we have a lot of equipment here. But can you see anyone?
I can
Well,
see the little guy one
oh
in the left
yeah,
of the
we have
telescope.
we have someone here, right? Yeah, I'm gonna do close up, and yes, we can see a person here. So you can take you can have a better idea of how big is this telescope and this facility. Okay, so this person is just below the blue structure. Okay, this reference helps us to distinguish the telescope itself from the rest of the structure, which you will now see in detail. So we have three things we can see on the right side picture. I will show you now. I will show you a picture now here. So pay attention to this picture here. In this picture we have in dark blue, we find the structure supporting the telescope itself, basically the mounting. Okay, so the mounting works as a huge arm supporting the telescope and includes a lot of systems that provide the power, such as electricity. Okay, so in this case, on this arm and parallel to the Earth rotation axis, the telescope moves to follow objects in the sky during the observation. Now, going upwards in lighter blue, I mean in this area, okay, we have a different color here. We have the telescope's body, which holds the 3.6 meter or 360 centimeters main mirror and the secondary mirror. Okay, so again, the main mirror or the primary mirror, the 3.6 meters, is located here, and the secondary mirror is located there. Okay, so in this case, where is the main mirror? Well, the main mirror is not visible right now because it's covered by its protection system. I mean, this black structure, and this structure is basically protecting the mirror against dust, for example. Okay, so the main mirror is located there. Now, this is a system of tabs, basically, which is opening and closing to protect the mirror, as I told you before. Uh, During this time when the telescope is resting or in parking position. Now, in the black tubular structure in the upper part, we have the secondary mirror, which gathers light from the main mirror in a beam and directs it to the instruments that analyze it. You will notice that the main mirror has a hole in the middle there. Can you see? So in this case, in well, you can see that the light is basically sent to the instruments through it. Okay? So that's the purpose of this holder. Okay. So now, where is the instrument, the actual equipment to analyze the data? Well, as I told you before, is called HARPS, and HARPS is a very special instrument because it's a planet hunter. So when I say a planet hunter, is something very, very special. Maybe we have a video to show. Yeah, this one. Uh, Harps is basically analyzing something here, because in this animation you can see that we have a planet, an exoplanet orbiting a star, that because the exoplanet has a certain mass and it has some kind of gravitational influence on the star, in the same way, like, of course, the star has a gravitational influence on the planet. Well, the star in this case is doing some movement, okay, is bouncing, and this kind of movement, okay, is reflected on the spectrum. So you can see how the absorption lines are going left and right. So this is a very good signal that the star is being influenced by an exoplanet, and this exoplanet detection system is called radial velocity. So basically, HARPS is analyzing this kind of phenomenon, okay, and we can have an idea if the planet, oh, sorry, if the star has a planet orbiting, uh, orbiting, okay. So HARPS is not visible. The instrument is not visible because it's completely isolated in another room, okay? Basically in another floor of the building. Okay, so okay, Felipe, I think we are clear with this video, so we can come back. Okay, thank you. So the 360 began operations in 1977, and from the beginning, it represented a challenge for the engineering and for ESO as an organization. The European astronomy gathered talents from several countries to build an optical telescope in the 4-meter category, the largest and most advanced category that existed at the time. So, why was such a large telescope needed? Well, in astronomy, objects are analyzed through the light. Okay, so the more light we collect, the more we can learn. In this case, a bigger mirror will capture more light and therefore more information will be available. We will be able to see fainter objects and smaller details. Now, how do you think this giant telescope moves? Well, um, Felipe can show a short video to take a look
Sure,
at this.
look at this video. This video is the principal move of the 3.6. It's very big one.
Okay, thank you very much. So, yeah, this was how basically the telescope is moving in normal operations. Okay, okay. And the last information I can give you at this point. Well, a mirror for astronomy is not just any mirror. Okay, since its shape and surface must be perfect at the scale of fractions of thousands of millimeters. So to achieve this in the 1970s, an extremely thick mirror was manufactured, 53 centimeters thick on average. But this also implies an extremely heavy mirror. So the mirror weighs 11 tons, the equivalent of 2 African elephants. So if we want to build larger telescopes, we need to find other solutions. So how was the next step taken? We will see it later with the NTT, okay? The next telescope uh, let's
Oh,
say for these two, okay? Okay, so I think at this time we have some time for questions. So Felipe, I don't know if we have some questions
we
from the
have
public.
we have a lot of greetings from Amsterdam, Ireland, Italy, Brazil, Vietnam, and cordial greeting from the Free of the Sea Observatory of Julio Gabarito Society for the Study of Astronomy. And here is a one question regarding the type of metal used for observatory telescope. Do you use aluminum? Why or why not? Usually, the telescope used in this particular 3.6 telescope use a solid metal and aluminium too. The reason is more efficient for temperature or for weight or for different reason or for better construction of building on an easy way to move the telescope because the weight of telescope is too heavy to move the simpler way. So for that reason, use aluminum in the principal part of the instrument or dome or different special parts. We need to more less heavy. This is the way. The next one, the entity, it's more the more part of building is aluminum parts. You can see in the in this tour. This is the only question I have. So I invite you to put different questions whenever you want to know about the La Silla, the telescope, or astronomy. You're welcome to put it in the chat box. So Farid is now the time to continue to the next telescope too.
Yeah, sure, sure. And just to complement your answer regarding aluminium, well, um, it's not it's not the entire structure made of aluminium. Okay. And usually on this kind of telescopes you have some kind of ceramic structure. Okay, but aluminium is only the reflective layer, and it's a very thin layer of aluminium. So it's only a reflective material, and that's why that's the usual material, the reflective layer of an astronomical mirror. And the other common material is silver. Okay, so basically silver and aluminium are the common materials used for the reflective layer of the mirror. Okay? Okay, now we are going to continue, and we are going to leave the inside of the 360. And so we are going to change the view. Okay, so from this location, and before our next stop, the NTT telescope, I would like to highlight the difference between the domes. Okay, so keep in mind that both telescopes have almost the same mirror diameter. Okay, for example, we have this dome, this classical dome, for a 3.6-meter telescope, and here we have a different concept. Oh, sorry, um, let me show you. This is a different shape of dome. Okay, so in the case of the um, in the case of the NTT, you can see that this structure is different. Okay, it's a little bit different. So let's talk a bit about the NTT. Okay, so the NTT was inaugurated in 1989. Okay, it has a small and very compact octagonal dome with a system of flaps. This represented in its days an evolutionary leap in the construction of telescope, since it's allowed hosting instruments in smaller, lighter structures with improved airflow on the inside. One were the more classical and massive domes, such as the 360. In fact, these flaps allow air to flow smoothly, reducing turbulence and preserving the sharpness of image. Okay, so now, as I told you before, this is the inside of the NTT. Okay, you can see more or less what was the is the shape. Okay, so if you remember the structure of the 360 telescope, well, that one is a huge dome, and the telescope is also a very big structure. Okay, so and of course the person working in the inside, if you remember, this person looked very very small. Okay, but now in this case, the building the NTT building is practically attached to the telescope. Okay, so again, you can see how compact is this structure here. Okay, it's very, very compact. So in this case, um, as I told you before, the building is practically attached to the telescope, and if we stand in front of it, we will look approximately this size. Okay, so the telescope mounting is also completely different. So here the entire building spins around 360 degrees. So you can see the mirror, the main mirror on a pale color around the structure. The mirror is here. Okay, I can show you another view of the telescope from here. You can see the mirror from there. Okay, this is the opposite side, as you can see. So we have the mirror there. But in this case, as I told you before, the entire building spins. Okay, and you can see the main mirror. But in this case, the disk, this disk is the mirror. Okay, and we can see that it reflects some light. Now, do you remember the 53 centimeters thick mirror on the 360, right? Well, the entity mirror has almost the same diameter as the 360. It's actually 3.58 meters to be precise. Okay, so it's more or less the same like the 360. Okay, oh sorry, the 360 can be seen from this picture there. Okay, so this big dome houses the 3.6 meter mirror, and this one, much more compact, houses the 3.58. So it's almost the same. Okay. Now, in this case, it is significantly thinner. Okay. In this case, the entity mirror is only 24 centimeters thick. It's also much lighter, 6 tons. Okay, just one elephant. Okay. Now, to keep a perfect shape as the telescope moves, there is a system of actuators or pistons below the mirror. The mirror, sorry, the system is enclosed inside a box that you can see just below the mirror. Okay, there. Okay, so we have something that we call actuators. Okay, okay. So in this case, we have 75 actuators going up and down to keep a perfect shape. So this system is computer controlled and is called active optics. That's the reason of the actuators. Now, active optics was developed by ESO and represented a significant technological breakthrough in the construction of the next generation of telescopes in the 10-meter category. Active optics has been applied to all large modern telescopes, including the Very Large Telescope or VLT at Parallel Observatory, and the upcoming Extremely Large Telescope or ELT um, that is currently being built near Paranal. So where's the staff? Well, around 30 people work in La Silla on different telescopes and tasks. So the scientific and technical staff is working in the control room of La Silla Observatory, which is located in a building quite far from here. So um, let's take a look. Let's take a look now in order to understand this concept. We can see La Silla at night, for example,
This
and
is
we have,
the sorry. This is
yeah,
the principal control room. In the right side, have a
yes,
3.6, the 3.6 control room, and the left side have a ATT control room.
yes, yes. So we have a view of the telescopes at night, and and the control room is separated from here. Okay, let me come back, please. And now we are going to change the location.
In the control room, we have a
Yes.
different investigation, and I put a video of ESO top 10 of the principal research in the ESO generally for Prananal of La Silla or Alma. So let me show you this video.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when two independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, well, this was a short video about the discoveries at ESO sites. So, Felipe, I don't know if you have some questions from the public to answer
Yes, we
right
have
now.
a more question to have. The first is, entity is a alt azimuth mount.
Yeah, the MTT, as you can see, is different because it's a different structure. So if we come back to the NTT, maybe it's visible, right? We have this kind of columns providing the altitude and azimuth, sorry, the altitude movement, okay? And yeah, the 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 dome itself is spinning, so yeah, it's essentially an azimuth mount, yes.
The next question, I'm reading from Germany. Entity use adaptative. The entity don't have a adaptative, but have a active optics. But the in parallel have a adaptative, yes, right? In parallel,
Yes. In Panorama, we have active and adaptive optics, and including a laser guide system. But maybe it's also important to mention that the La Silla Observatory has also been testing adaptive optics from a long time ago with specific instruments. For example, there is an instrument called Adonis in the this has been tested in La Silla. Adonis is an acronym for Adaptive Optics Near Infrared System. This was the first user-friendly adaptive optics system attached to the ISO 3.6-meter telescope in La Silla. But yeah, now if you want to talk about the more relevant adaptive optic system, yeah, in Paraná we have that. Yeah.
is from Limache, Chile. Hi, hi. Is that place what is the job of the instrument operator? Yes, is this observatory have instrument operators or operator of the telescope, have a different kinds of people that are working inside and outside of the telescope. So yes,
Yeah,
this is the job for instrument operators.
Yeah, the instrument operator is basically in charge to move the telescope using the computer. Yeah. So, and this is the kind of people that you were able to see in the short video that Felipe was showing you before.
So the other thing I need to show is the part of the ESO.org. This is the principal page of all information you need to know about the ESO, photos, and the recent research of the astronomy. The NEO 1 billion pixel ESO image shows running chicken nebula in the present details, and more news about the astronomy. And the other thing, you can visit the different observatories of ESO in Chile. Is completely free to visit. So you can go to about and visit the ESO Chile, visit the Paranal of or La Silla. You can visit both or one of whatever you want to go. So I invite you to see the page and visit the observatories in Chile. It's a beautiful place. This is the beauty place to see. So what is the next? What is the next, Farid?
Yeah, well, the next and before coming to the tour, we have a bonus track regarding the ISO top 10. So we have an extra result. So please, Felipe, can you please display the video regarding the black hole discovery?
Oh yes, let me show you the black hole here. Here's the video of the black hole.
Oh, okay, thank you. So basically, this is something very interesting because in 2019, a team of astronomers captured the first image of a black hole. The Event Horizon Telescope, or EHT, well, is an array of 8 ground-based telescopes distributed across the planet, coordinated by an international collaboration, and they achieved the first direct visual evidence of a supermassive black hole, as you can see in a few moments. The image, the image reveals the black hole at the center of Messier 87, a massive galaxy in the nearby Virgo galaxy cluster. This black hole is 55 million light years from Earth and has a mass 6.5 billion times that of the Sun. Okay, okay. So this was
The little
uh,
bonus.
yeah. So this was an important summary of the discoveries made at ISO sites. Okay, and of course those discoveries are possible with the help of our amazing scientific staff. Okay. Okay. So now the tour goes on, and the night falls over La Silla. So there is no moon, and we can take a look at the night sky. And I think it's important to show you this perspective first, okay? Because from this picture, you can see the night sky. We are for example, at this moment, we are in the platform of 30.6 meter, and we can see that there is something here. This is something important to mention because this is the light pollution from La Serena, Coquimbo. It's important because any astronomical observatory has to fight against the light pollution and to make sure that telescopes and all the scientific facilities can operate and take advantage of the dark skies. We can see here, for example, more light pollution from the road. Okay, and as far as I know, this is I think it's Vallenar, right, Felipe? This one here.
Yes, that's right. It's Vallenar City in the north part of the La Silla.
Okay, yeah. So that's why it's important to mention the light pollution issue. Okay, okay. So now we have well the dark skies, as you can see, and the first important thing we can see here. I let me show you. We have something here. We have a very important constellation. This constellation is very well known. Okay, it's Orion, the Great Hunter. Okay, this one here. So let me do a close up. This is the Orion constellation, and the Orion constellation it represents Hunter. Okay, with this belt. Okay, this one. This is the Orion's belt. In Spanish, in particular in Chile, we associate this kind of stars with something we call the Tres Marias or Three Marys. Okay? So in this case, Orion in the mythology may be tired, maybe after a long journey across the sky. Okay, Orion at some point is going to set over the horizon. Okay, the hunter and the great dog that accompanies him, or Canis Major, have been following a particular path through the sky. Okay, the Milky Way, our galaxy. When I say the hunter and the great dog, okay, I mean there is another important astronomical object near Orion, and it's this one. This star is the brightest star in the sky, and it's called Sirius. And this star belongs to a constellation called Canis Major. And Canis Major is one of the hunting dogs of Orion. So basically, it's related in the mythology. This constellation, Canis Major, is related to Orion. Okay, so this is important to know because we can see that many astronomical objects are, let's say, connected in the mythology. Okay, okay. So our galaxy, regarding our galaxy, well, it's basically a huge flattened disk shaped as a spiral, barred spiral, but we see it as a band of light across the sky because of our viewpoint, since we are inside the disk. Okay, so for example, here we can see one of the Milky Way arms. Okay, and you can see it very clear because this area has much more stars. Okay, if you compare with other areas of the sky. Now, in this case, our galaxy consists of around 200 billion stars, okay, and huge clouds of interstellar gas and dust. Okay, we can see the later as dark clouds that cross the band of light. Okay, and the red clouds instead are made of hydrogen, the simplest and most plentiful element in the universe, from which stars are formed. Okay. Okay, so by looking through the Milky Way, we will find two strange objects similar to clouds. Okay, so let me change the view because we have to change to another perspective from here. Let me try to come back. Okay. There. Okay, we have something very important here. Okay. Let me try to change the location. Okay, so we have something very important here. As you can see, there is some, let's say, spots in the sky, these blue spots. Okay. In this case, we have two strange objects. Okay, we can say that they are similar to clouds. Okay, in fact, these are the large and the small Magellanic clouds. The large Magellanic cloud here and the small Magellanic cloud there. And the Magellanic Clouds are our closest neighboring galaxies. Okay? At the same time, they are smaller than our Milky Way. They have that name because it was identified as clouds from Ferdinand Magellan during the circumnavigation of the planet, okay, around the 16th century. So at that time, no one has any idea of what a galaxy is. Okay, so at that time, those objects were identified as only clouds. Okay, but now we call them the large and small Magellanic Cloud, but we know that they are galaxies in actual. Okay. Now, of course, nobody knew what a galaxy was at that time, but today we know that galaxies are systems hosting tens of billions of stars, and that these are classified as irregular due to their shape. These typical objects of the southern sky also indicate the position of the south celestial pole. So we have to use a reference to find this south celestial pole, because the south celestial pole is basically a point in the sky, and and the stars surrounding this south celestial pole are revolving it. Okay, so because we don't have any bright star next to the south celestial pole, we have to find some way to find it in the sky. That the south celestial pole is more or less in this location, okay? But we don't have any bright stars there, so we have to find some kind of let's say replacement to to know where the south celestial pole is. Okay, so in this case, to know where the celestial pole is, okay, we have to use a constellation. We have to use the Southern Cross. The Southern Cross is the smallest constellation in the sky, okay, and is located there. In this case, the Southern Cross looks tilted, okay, but you can see the shape. Okay, this is the shape of the Southern Cross, and the only way to find, in this case, the South Celestial Pole is to project the longer stick four times and a half. So we project this 1, 2, 3, 4.5, and more or less like here, approximately, we have the South Celestial Pole. Also, if you look at that place in the horizon, okay, we have this the South Cardinal Point. Okay, so this maybe could be useful if someone get lost in the desert. Okay, so this is the importance of the South Celestial Pole and the Southern Cross to find that specific point in the sky. Okay, so now if we continue exploring our Milky Way, this will take us back to the 360. Okay, and behind this, the center of our galaxy rise. Okay, so we can see how the galaxy, okay, the Milky Way, is there. Okay, and of course, it's very, very impressive to see this very important view from La Silla at night. Okay. Okay, so now we are going
To the
to
final
change a
part.
little bit the view, right? Because we have to go to the hotel of La Silla Observatory. Um, we can change.
One of the question for people is
Okay, so
what level is this site? The site of La
it's
Silla level is around the 2,400 meters over the sea. This is the the level of the La Silla. It's not too much, but this is considerable altitude.
yes, exactly. Yes. Any other question?
Let me see. This is okay. What you do. I appreciate the opportunity. This is a greeting. Thank you for your greetings. And the indigenous Australian refer to Orion as a canoe. Oh, interesting. The canoe for Australians. And how manage times the telescope? How the people manage the time of different telescope in La Silla? This must be a very busy equipment. Yes, this is a busy, but the manage of the time of telescope is in Germany. Manage the time of different nights of the during the years of the La Silla telescope. So The manage is in different parts. You the first the astronomer must be the right the solitude solicitude for use one particular telescope in that way and that object and send to the Germany and Germany in the Germany HQ see the one research and compare it with the others in the same night and the priority have the most important research for use the telescope so that the astronomer when win the night when uh, all is free for them so he can go to the La Silla telescope and start to see the sky but the time of the astronomer right and the astronomer go to the La Silla pass around 1 year. It's 1 year to move the for the paper to the for the I um, the observatory. Sorry. And the others the question is there a comment on the area on the left side and see or I'm seeing wrong? In the photo you can see different things in this particular visit, right? But it is last part in the next visit you can see better the part of the Orion comet and this is the all question we have. Thank you for your questions too.
Yeah, I think
I'm looking for
that
Orion. Uh, uh,
yeah,
uh,
I think that question is referring to this image because we see a comet
ah,
here. Okay, yeah, that comet is the comet Lovejoy. That comet was visible from La Silla some time ago in 2015, and that's why we have the comet there. So yeah, it's very nice. Yeah. Okay. Okay, guys. So we are going to finish this presentation, and for that, I'm going to visit
the hotel.
the hotel. Yes, we are going to take a look at the hotel. And this is the photographer who was in charge of the pictures you saw on this tour. And of course, we have a very nice view from the hotel. In this place, we have all the people working in the observatory. They can rest here and they can enjoy this beautiful view of the night sky. Okay, so basically, this is now the end of this experience. I just want to mention again, this is the place where the observatory staff can rest and spend some time until the start of the next working shift. Okay. Okay. So, Felipe, I don't know if there is something else to mention. Any last question,
Uh,
or we are ready to finish?
thank you very much for the presentation. Says Garavito Society of and thank you for the question. Thank you. The next week is Paranal visit online. You can see in Spanish and English is half. The next is in Spanish, right? Paranal
Yeah, yeah,
the next week.
exactly. We are changing La Silla and Pananal, and we are of course alternating in English and Spanish. Yes, yes. Okay, okay, perfect. Thank you, Felipe. And I would like to remind you that all these visits, information, images, and material are available on the ESO website. In this case, eso.org. And of course, we have a lot of interesting pictures and videos, and you can explore by yourself. Okay. Okay, so now please stay in touch with the ESO social networks to take a look at our next virtual tour. And I would like to say thank you very much to all the visitors, the virtual visitors we have today. We hope you enjoy this tour. And on behalf of ESO, we thank you very much for your presence. See you soon.
See you soon.